So, say solving an equation with radical expressions like this: x plus 2 square root times the square root of x minus 1 is equal to 9. And the first step you should do is to move everything with the radical sign to one side and everything that doesn't have a radical sign to the other side. In this case, the x we can subtract, let's redo that. The x we can subtract from both sides of the equation, and then this ends up looking like 2 square root of x minus 1 is equal to 9 minus x. Now remember, the 2 is connected to the x minus 1 by multiplication, so subtracting a 2 from each side would actually be an error. Now you can divide both sides of the equation by 2 to get rid of this 2, but it's actually just going to create more work for you. So let's leave that 2 as is. And now we can apply the squaring property of equality and square both sides of the equation. Now in the left, the square root distributes into the product, right? Because when you have a times b squared, this becomes a squared times b squared. So simplifying the left, we get 2 squared times the square root of x minus 1 squared. And then on the right, this is, you're squaring the whole thing, so you're multiplying it by itself. So this is going to look like 9 minus x, times 9 minus x. So simplifying this further, 2 squared becomes 4, and when you square a square root, they cancel out, and we're left with 4 times x minus 1. And remember, because these are two separate things, you have to put that x minus 1 in parentheses. It's not going to become, 4x minus 1. So just keep that in mind. Now on the left side, what we do is we can use the FOIL method. So the FOIL method, it's first, so 9 times 9, which is 81. Plus outer, so 9 times negative x, which is minus 9x, and plus inner, which is again 9 times negative x, which is minus 9x, and then last, which is negative x times negative x, so we get plus x squared. Now simplifying these further, we distribute the 4 into this difference, so we get 4x minus 4 equals, simplifying, we get 81 minus 18x plus x squared. Let me rewrite that squared. Looks a little weird. Alright, much better. So now we want to move everything to one side, because notice that this is a trinomial, and usually when we see a trinomial, we try to factor it. So we want to get it to look like, ax squared plus bx plus c is equal to 0, so we can see if we can factor these. So by doing so, we move everything over to one side. So let's subtract a 4x from each side, and should have done that in a different color, but what can you do? And we'll add a 4 to each side. So this equation is going to look like 0 is equal to 81 plus 4, that's 85, minus 18x minus 4x, that's going to be, let me write this 5 over, minus 22x plus x squared. And again, since addition is commutative, I'm going to rearrange these terms and write the equals sign on the other side. So this simplifies to 8x squared minus 22x plus 85 is equal to 0. So now we want to find two numbers that when you multiply them give you positive 85, and when you add them give you negative 22. And as it turns out, 85 factors into 17 and 5, which if you add them together, negative 17 and negative 5, which if you add them together would give you negative 22. So this becomes x minus 17 times x minus 5 which is equal to 0. And then using the 0 factor property, we know that x minus 17 is equal to 0, or x minus 5 is equal to 0. So x is equal to 17, or x is equal to 5. Now, we have our solutions, and since we ended up squaring our equation at some point being, right up here, what we have to do is we have to check our solutions to make sure that both of them check out. So we want to plug in 17 and 5 into the original equation, which is x plus 2 square root of x minus 1 is equal to 9. So, check. We want to plug x equals 17 and x equals 5 into the original equation, which was x plus 2 square root of x minus 1 is equal to 9, just so that we could remind ourselves. So let's do the first case. X is equal to 17. So replacing all the x's we see with 17s, we get 17 plus 2 times square root of 17 minus 1, and we want to see if it's equal to 9. And that's the reason why I put the little question mark over the equal sign, is because I'm not asserting that they're equal, I'm checking to see whether it's true. So simplifying further, this becomes 17 plus 2 times square root of 16, and we want to see if this is equal to 9. So 17 plus 2 times square root of 16, which is 4, and we want to see if it's equal to 9. So finally, simplifying, we get 17 plus 8. Let's see, it's equal to 9, and we can see 17 plus 8 is 25, which is not equal to 9. So 17 actually doesn't work as a solution. And in this case, we write that x is equal to 17 is an extraneous solution. Just a little bit of terminology for you there. So now that we've checked 17, let's check the other one to see if that works. X is equal to 5. So wherever we see an x, we plug in a 5. So we got 5 plus 2 times square root of 5 minus 1. I almost wrote an x there. And we want to see if that's equal to 9. So, scrolling down a little bit, 5 plus 2 times square root of 4. Let's see if it's equal to 9. 5 plus 2, square root of 4 is 2. Want to see if it's equal to 9. 2 times 2 is 4. And finally, 5 plus 4, as it turns out, is 9. So this equation checks. So now, since we have an extraneous solution and a regular solution, and a solution that works, rather, we should write down that the solution to the equation is x is equal to 5, and if you want, you could write a little extra note here. X is equal to 17 is an extraneous solution. Just giving as much information as possible as your answer. So there we go. The solution is x is equal to 5.